Ladies and gentlemen, please put your hands together and welcome to the stage your host, Matt Parker. Calm down. So, thank you all very much for coming along in a reasonably quick and orderly fashion. It is difficult to get 430 teachers together facing the same direction at the same time, and so far you are doing a great job. My name is Matt Parker. It's my job to be your host for the duration of Science on Stage 2015. So you will see me come out. I will be nice to you occasionally from on stage. I will let you know what's happening next, and if you've got any general questions, you can ask me. I will not know the answer, but I will know someone who does, and so I will then pass you on to them. I also have to do all the health and safety, so I should make it very clear before we start, if at any point tonight, any time during tonight's show, if anything at all, I mean, anything on stage, anything in the audience, if anything catches on fire, that catches on fire that we don't want to be on fire, you need to very calmly stand up, walk away from whatever is on fire, even if it's a friend of yours. Very calmly, there's an exit over here, you can go out, or there is an exit over there. People at the back, jump, I guess. Although there's an exit, there is an exit over there, and there is an exit over there. If the thing that is on fire happens to be one of the exits, please use a different one. We are not expecting anything to go wrong. So if you do hear an alarm, then that is a genuine emergency or something has happened. So there are no planned rehearsals. If you hear an alarm, very calmly stand out and wander out of the room. Okay, so tonight, this is our opening ceremony. We have a series of various people related to science education who are going to come up and talk to you. In terms of my background, I actually used to be a teacher. I used to be a maths teacher back in the... I'm from Australia originally. I taught maths in Australia for a couple of years. I thought not enough students are throwing chairs at me, and so I came to London, and that fixed that. And I then taught in London for a few years, and I very gradually drifted from being a normal classroom teacher to now I work part-time for Queen Mary University of London, so I'm in the maths department here, and I do mathematics communication work. I also do all sorts of writing and media and anything I can do to get more people more excited about mathematics. Most of my TV and radio work is done with the BBC. So the one thing you might have seen, actually, I'm currently a presenter on a TV show on the Discovery Channel, which means no one is watching it. And I do a lot of work on YouTube. So if I look familiar, but bigger than usual, I do the Number File channel and a few other YouTube channels here and there. So if anyone wants to come and see me over the course of Science on Stage, you can come up, say hello. Happy to talk about YouTube or media or anything else I do. But officially, from now on, my job is to be here on stage and to be nice with you and make sure you're having a good time. So we're going to start with some science live on stage. So our very first thing we're going to bring to you tonight is called the Science of Santa. And so I'm not going to give you any more details behind what that involves. It's a fantastic collaboration from the University of East Anglia, which is a university about halfway up England on the right. And in there, one of the primary school teachers who works on their teacher training worked with a member from their chemistry department. And so they worked together to put together the Science of Santa. It is traditionally aimed at a kind of classroom setting and to help teachers use narrative in science teaching. And as you may have noticed, there's more than one standard classroom of us in here. In fact, there's about 10, there's would that be a deci classroom, or was that a tenth of a class? There's 10 times the normal number of people. So what we're showing you tonight was built for a classroom, so you just have to, particularly the people right at the back, have to imagine you're in a close classroom environment and see how this would work for you in your classrooms. And so, without any further ado, I think they are poised and ready to go. From the University of East Anglia, can you please put your hands together for Maxine and Stephen?
Thank you. So the concept behind this idea came from the need to try and put things into context for very young children to help them to understand the science going behind it. So we put together the idea of using a story to try and link a series of science demonstrations to help small children understand not only what's going on, but also to give them some context in which to base the demonstrations. So we put together the show. It was aimed really at children between 8 to 12 years. It formed part of the UEA Children's Christmas Lecture last year. And what we want you to do as we go through the show is not just to sit there and watch, but also to think, well, how could I change this? How could I adapt the ideas here to make it relevant to the children, the age of the children in my class, the topic we're studying, and the interests of the children? Okay, so our story starts in around about November, and in the UK, in this time, children are getting very hyped up about Christmas. There are advertisements, shop fronts, toys galore, and children are constantly spending their time saying, I'd like that for Christmas, I'd like that for Christmas. And the parent's response is usually, well, write it down in a letter to Santa. Now in the UK, it's quite traditional that once children have written a letter to Santa, that they send it up the chimney. There's a fire burning in the fireplace, the letter goes into the fireplace, and up the chimney it goes. And apparently, it gets to Santa. But my question is, why doesn't the letter burn as it goes up the chimney to Santa? How can we stop that letter burning? The answer is in a secret that only parents know, or I hope they do, otherwise the letter will burn. Stephen is going to tell us just what that secret is.
Well, Maxine has a letter for me, I believe. I hope. Thank you very much. So this has been written before. Oh, you want one of those this year, do you? So I have a liquid here, a special liquid that I'm going to use, and we'll see what happens when I work before the show. When I set that piece of paper alight, we'll see that it burns and the letter would still be legible because there is actually no charring at all on that paper. Now, what's the secret of the liquid? It's a 50-50 mixture of alcohol, which is burning, and water. And the beauty of that is that water, in evaporating, keeps the temperature of the paper low, and it doesn't reach the ignition point, the ignition temperature of paper. We might know the ignition temperature of paper, at least in Fahrenheit, because it's the title of a famous book, Fahrenheit 451.
Thank you. So Santa is collecting these letters from the children, but him and his elves are already hard at work making the presents, wrapping the presents and storing the presents. Now, it's always eluded scientists as to just whereabouts this happens. But the suggestion is that if all of these toys are being made, there must be huge amounts of raw materials being delivered to the North Pole. And in England, I'm not sure about other European countries, it's very common that when goods are delivered by our larger delivery companies such as Amazon, we get huge packages. We open up the package and inside there is lots and lots of polystyrene packaging, and eventually we pull out the tiny memory stick or something that we've ordered. Now, if that's the case, Santa and his team of elves must be working with a huge amount of polystyrene packaging. Just what do they do with all of this packaging? Now, as scientists, we can build hypotheses, and one hypothesis is that actually the North Pole itself is not covered in snow and ice at all. It's covered in huge amounts of polystyrene that Santa gets from his raw materials. Now, as scientists, we want to test the hypotheses. And if that is the case, we'd expect that year on year, the size of the North Pole is getting bigger and bigger and bigger. But actually, we've done those tests, and what we know is that it's smaller and smaller. So Santa must be doing something else with his polystyrene packaging. Stephen, what do we think he might be doing with it?
Well, I have some polystyrene packaging here, and I have another wonderful liquid here. This is acetone. I was kindly given acetone by the chemistry department here. Now, normally I would buy this in the builder's warehouse, and I know that acetone is an ingredient in a nail polish remover. So I can only assume that this acetone is what builders use to remove their nail polish. But if you take our acetone and our polystyrene, we can see that Santa may have a way of getting rid of it by dissolving it.
Now, you may find this hard to believe, but a team of scientists and economists have actually estimated that Santa would need a warehouse the size of 240,000 double-decker buses in order to store the presents for all the children across the world. Now, if that's how he stores the presents, the question then starts as to how does he fit those presents into his sack? We feel that this is one of the reasons why he lives at the North Pole. The fact the North Pole is so cold, maybe we start to think about liquid nitrogen and the idea that if you put things into liquid nitrogen, they would shrink. Now, that brings with it a problem that actually by putting things into liquid nitrogen, it makes them very brittle. And so, the next thing Santa has to think about once he's got them all in his sack is how to protect them. And if you come to our stand that we've got, we'll help you to try and think of one of the things we've got as to how Santa might protect the presents that he uses. We'll also help you understand how Santa might remain invisible. In fact, on our stand, we've actually got Santa's sleigh, and indeed, we have made it invisible. So come along and have a look, and we'll show you. We'll also try and help you answer the question, why is it that Santa is so fat? He spends his whole time going up and down chimneys. Surely it would be better if Santa was much slimmer. But no, Santa is always depicted as a very fat and jolly fellow. So why is it that he's so fat? Well, we'll try and help you answer some of those questions on our stand. But what we're moving on to now is to think, how does Santa get down that chimney? The fact he's a very large fella, he can't just slide down easily. So I'm going to hand you over to Stephen, who's going to try and answer this question for us.
Well, once upon a time, we would heat our houses by roaring fires. Some of us may still heat our houses that way. We'd have a roaring fire, and then we'd put it out at night, and the idea is that Santa would be able to come down the chimney in some magical fashion. But of course, these days, we no longer tend to have roaring fires, but nevertheless, we may find that our house cools during the night. And I've just made my living room here very, very warm by putting some warm water in it. And I have a model Santa here. And with luck, as my room cools, you'll find that being a fat Santa has a distinct advantage because it plugs the chimney, and as the room cools beneath him. Now, occasionally, my model Santa doesn't make it to the living room in one piece. But it's cooling nicely, and he's going in there slowly. Have to talk amongst yourselves for a moment or two. You could also try this by burning something in a conical flask. That would represent the old-fashioned way. There we go. I don't think he's going to make it in one piece today. So unfortunately his boots fell off. It's always best, if you are going to do this, to be able to match the size of your flask to your egg better. But now, of course, this was my lunch, and I'd rather like to eat it. And the question is how to get it out of there without smashing the conical flask and having lots of shards of glass. Now, I can use the same principle as I did before, I hope. And Santa will actually come out.
So, Stephen, how did he get down the chimney? What was the science behind it?
Well, the science behind it was the cooling air. The cooling air takes up less space in the room because he was neatly plugging the chimney with all his fat. That cooling air contracted and pulled him down the chimney. And of course, if Santa visits, you get a free chimney sweep at the same time.
So, Santa makes his way down the chimney, he fills up the stockings with the presents, and then, as he's starting to leave, his attention turns to the fireplace. Now again, I can't speak for all European countries, but in England, it's quite traditional to leave at the fire some carrots, some sherry, and a mince pie. Now, you might think the carrots are there for the reindeers, and the sherry and the mince pie are there for Santa to eat. Well, we've got some other theories behind that. If Santa, and again it's these scientists and economists who've done this calculation, was to consume a small glass of sherry and a small mince pie in every household he visited, he would eat about 150 billion calories just on Christmas Eve alone. And we know that that's not particularly healthy for poor old Santa there. So our theory is that he uses these for other things, and that maybe he uses them as fuel to get himself back out of the chimney. Stephen, how could he use these items that we leave?
Okay, well, one thing is the sherry. We wouldn't want Santa drunk in charge of a sleigh, so I have some sherry substitute here. It's actually surgical spirit. You can often use methanol for this trick, but surgical spirit is a mixture of methanol and ethanol, and also some nasty things that make you not want to drink it. What I'm doing here is mixing the vapor of that mixture with air in a large bottle. Now, these are quite expensive if you want to buy one, quite expensive with a deposit if you want to steal one. So what I do is go to my local water cooler company and get the ones, they're happy to give away the ones that they no longer think are fit for filling with water. So I've got a nice mixture of vapor and air in here now, and so this could be what Santa uses to fuel his ascent through the chimney. And what I'm going to do is ask for the lights to be put down, please. And with so that's how he might use the sherry instead of drinking it.
But what happens if he does fancy a drink?
Well, if he does want the sherry, and I'm sure he does every once in a while, there's always the mince pie. And you'll notice that there is a light dusting of icing sugar. Now, I don't have icing sugar because when I'm forced to clear up after this particular demonstration, I don't like the sticky mess that icing sugar leaves, so I have corn flour. And if Santa can make a nice cloud of his material, his corn flour or his icing sugar, then what he would be able to do is, again, fuel his ascent up the chimney. So I need to... And of course he will come equipped with a lighter that works. And if we could have the lights down again, please. So he might be able to do something like that to get himself back up the chimney.
Thank you. Okay, so what we've done just there is really give you a really short extract of the demonstration that we put together for the children and just picked out some of the ideas we had and the story we put together behind it. As we said, what we'd like you to do is not just to take this idea straight into your classroom, but to think of how you can take the concept of the story and some of the demonstrations and put them into something that will interest your children and be relevant for them. And one of the things we'd like that if you come to our stand is we'd like to talk to you about some of the ideas. I've put together an assembly just a few weeks ago based on very similar demonstrations on the theme of Harry Potter for the children in the school, in a primary school in Norwich. And so we'd love to come and talk to you about your ideas. If you do want to see the whole show, you can use the link there. And if you'd like to tweet, the hashtag that we're using is Science of Santa. So thank you very much for your time.
Maxine and Stephen, ladies and gentlemen. What is this? This is a trip hazard. My favourite moment of the entire thing was when Stephen got the lighter and there was click, nothing. Click, nothing. And a room full of science teachers, you all leant back and went, glad that's not me. Right, but you did. Now we have actually started the show with a bang. I should say though, please make sure you warn your students you are going to decapitate Santa before you do what would be quite a traumatic experiment. Do not draw Santa's face on the egg, because when that falls off they get very upset. Alright, so a quick bit of lights up very quickly. We've lost one of our Finns. Elna from the Finnish contingent. Where are you? Elna from Finland. Are you in? Finns? You're over there. Right, the Finnish ambassador is trying to find you. So you've not done anything wrong. You're not like, I'm going to find her. Right, he wants to say hello. So that's her over there. It's nice to meet you guys. I've been to Tampere Institute of Technology. And Tampere is a fantastic place to go and do science. Love. No one else is enjoying this conversation, but we are having a great time. Lights back down again before it gets awkward. So, up next, we have someone who works here at Queen Mary University of London. They are, well, first of all, they are one of our professors of computer science, and they've worked in the computer science department, but they are also the vice principal of public engagement and student enterprise. And as well as being a vice principal of the university, they do a fantastic amount of work actually going out and engaging young people in maths, science, and technology. So can you please put your hands together and welcome to the stage, hiding in the shadows, is Professor Peter McOwan.
Thank you everyone, and thank you Matt for that brief introduction. So as was mentioned, my name is Peter McOwan. I'm the Vice Principal here at Queen Mary for Public Engagement and Student Enterprise. And the first thing on my agenda for this evening is to welcome you all here to Queen Mary on behalf of the Principal and President, Professor Simon Gaskell, and to hope that you find this an extremely enjoyable, engaging and useful opportunity to meet together and to see some fascinating science and pick up some interesting ideas from interesting people doing interesting things. Just to say a little bit about the history of Queen Mary. So Queen Mary started off over 125 years ago as an experiment in Victorian philanthropy, and was set up actually as a music hall. And this is the Great Hall as part of that kind of music hall structure that we started from, to provide education and entertainment to the people of the east of London. And over the years, around the Great Hall and that kind of cultural aspect of things, grew up a series of educational opportunities, and through a series of amalgamations and joinings with things like the University of London, Queen Mary has established itself as a very preeminent member of the Russell Group of universities here within the UK. But one of the things that we've never forgotten during that time is the fact that we are started with our roots in the local community, and particularly the idea of the civic university of engagement with those around us, and the ability to raise aspirations both locally but also nationally, internationally, and therefore the opportunity to have this group of distinguished people coming from across the country and across Europe to here is really fantastic. As Matt said, as well as doing the kind of senior leadership aspect in college, I also go out and do public engagement myself. Part of the reason for that is because I enjoy doing it, because if I'm going to sit in an office and tell people they should be going out and doing it, I should get out there and do it myself. And it's just a great opportunity to be able to come out today and do a little bit of one of the things that I actually get up to in my spare time. So, as well as being a professor of computer science, I also use magic to teach mathematics and computer algorithms. And I'm going to give you the opportunity to see a little snippet of one of my shows from this. So I've been interested in magic ever since I was a kid, and I'm an amateur magician. I enjoy doing it as a hobby. In magic, there's a very famous trick known as the torn and restored card trick. And that involves showing somebody a deck of cards, asking them to select a card, then tearing that card up, making a magical pass over it, and restoring the card to its original unblemished form. Well, as I say, I'm an amateur magician. I can do one half of that trick. I can do the part where you tear the card up. But I thought that rather than do that, which probably wouldn't be all that impressive, I would try to do a little bit of mind control with you. So, what I'm going to do is I'm going to show you a selection of cards that I've chosen especially for this experiment in mind control. And I'm going to try and use the psychic power of my mind to make you all think of one particular card. And then I'll tear that card up. So, the instructions for this are very simple. I'll show you some cards. I want you to choose a card quickly. Just the first card that kind of jumps into your mind. Whatever you do, don't change your mind, just remember the name of that card. And when you've got that card firmly in your mind, remember it and put your hand up, okay? So everybody, by the end of this, should have been thinking of a card. So here we go. Remember, choose a card, the first card that jumps into your mind, but whatever you do not change your mind. Okay, here we are. Everyone should be choosing a card, everyone's hands should be up, everyone should be thinking of a card. Hands up, come on, hands up. Everybody, hands up, remembering the card, okay? Keep remembering the card. Keep your hands up until I tell you otherwise. Remember the card. Okay, so I'm going to shuffle the cards. Remember the card you're thinking about. I'm going to shuffle the cards again. Then I'm going to tear up the card. If I've torn up the card that you chose, put your hand down. Here we go. Little ripple there of astonishment in the audience. I didn't manage to get all of you, which is the way. It's difficult to project my mind into all of your brains. But obviously I managed to get a number of you, and that ripple of astonishment was an interesting thing. So, we're all scientists here. We have hypotheses. There are two alternatives here. One of them is that I genuinely can project a thought into the mind of the vast majority of this audience, which would actually be a pretty neat thing to be able to do, or alternatively it's a trick. So would anyone care to hazard a guess as to quite how that works. Sorry, none of the second cards were in the first batch. You were accusing me, a respectable professor of computer science, of doing this. Spot on. That is why a magician, I know, it's just so simple. That is why magicians will never reveal how they do their tricks. Because once you know where the elephant is hidden, the mystery goes out of it. So all of the cards on the first slide and all of the cards on the second slide were completely different, which meant that whatever card you memorized here wasn't there. So those of you who still had your hand up going, oh, my card's still there. They couldn't be. They were completely different cards. So this is actually a professional magic trick that's done with trick cards. It's called the Princess Card Trick. It goes back to about 1905. It's credited to an American magician called Henry Hardin. For me, this trick, the mechanics of this is very simple. But for me, actually, it's the science behind it that's of interest. So my research area is into artificial intelligence and trying to understand the way that human brains process information. And actually, the reason this trick works, for me, is as exciting as the fact that the trick works itself. So the first thing is that I do choose these cards carefully. I choose these cards that are a mixture of suits, it's a mixture of colours, and a mixture of high values. There's no obvious cards there, no ace of spades or queen of hearts. Okay? I then put you under pressure. I make you have to remember a card, and I put you under even further pressure by telling you not to change your mind. Of course, it wouldn't matter if you changed your mind, but you feel under pressure. What your brain does, it has to process billions of bits of data flowing into it all the time. So your brain makes approximations. It uses heuristics and rules in the way it processes information. And what it does, it pays attention to the card that you're remembering, because that's important to the task. After all, you've got your hand up. Who knows, I could be getting you to come up and tap dance on the stage and recall the card, so you better remember it. So you remember the card, and then you approximate all the rest of the cards. So you don't remember the details of these cards, you only remember the detail of this card. I then use something called time misdirection. Magicians do that all the time. They do about shuffling and shuffling again. And that means that there's time between you remembering the card and having to recall it later. And what that means is your brain's going, for example, 8 of diamonds, must remember 8 of diamonds. And slowly but surely, all the other detail of the other cards, which you never really memorized anyway, kind of drops away. So when I show you the final part, the final slide here, and I've set up this story about the torn and restored card trick, the story completes itself. There's a torn up card. Your card isn't there, therefore it must be that card. And because I do seem like a respectable professor of computer science, that story makes the pattern complete. Your brain likes it because the narrative has come to a conclusion. And that's where the magic comes from, because your brain is remembering things, is paying attention to one thing, the card you're remembering, and not remembering all of the others. So the next thing I would do in class would be to ask, what does this have to do with your MP3 player? Again, making it relevant to the sorts of things that school children and young people are interested in. I get a range of different suggestions there about shuffling, and somebody suggested they could tear an iPod up. It was a scary person, but eventually, maybe somebody, if not, I will prod in the right direction, mentions it's actually exactly the process that allows you to create an MP3 file. An MP3 is a data compression algorithm, and it contains a technique called psychoacoustic encoding. Psychoacoustic encoding. It's a very long word, but a very simple idea. And what it basically says is, if you're looking at the way the brain processes information in the sound domain, in the auditory domain, a loud sound will mask the presence of quieter sounds. So you pay attention to the loud sound, you don't notice that these quieter sounds, these quieter frequencies, can actually be removed from the signal. And that's exactly how MP3s work. They go through, it processes the signal, looks for these loud sounds, and removes the quieter sounds from around it, which means you can put more of music onto a disc inside your MP3 player because of that. So actually, every time you're listening to an MP3 track, the MP3, that piece of artificial intelligence software built in, is actually playing the same trick on your ears as I played on your eyes with the card trick. I'm then able to talk about the fact that you can begin to try and understand something more about how people see things. And part of my research here is in robotics. I can introduce the idea of visual saliency. I think it's useful for somebody who has a research background to let young people know about the exciting things you can start to do when you do maths and programming and so on. Something called visual saliency. So in visual saliency, it's a process that goes on in your brain, the early parts of the brain, visual cortex at the back. You take an image, you can then process it, and this computer program will actually score the different parts of the picture on the basis of how likely it is that your eyes will actually look at those particular points. So what you have is a situation here where, for example, this road sign has a high score, and if you look at this picture up here, you will tend to look at that road sign just because of the structure against the background and so on. So what you can do is you can create this model of the brain. How do you test it? Because scientists always want to test things and find out if it works. So what you can do is you can take a series of random pictures, you can put them through this algorithm, and then you can ask it to remove areas from the image. You can ask it to remove areas, for example, of a high visual saliency, or an area that has a low visual saliency. So the prediction would be an area with high visual saliency, you would notice that that had changed. An area with a low visual saliency, you might not. So this is an experiment where we can actually try it here again in the hall, and I'm going to pit my computer program against your brains and see how it does. So what I'm going to do now is I'm going to show you two pictures. The pictures are processed by the computer algorithm, which selects, in the first case, an area of high visual saliency and removes it from that picture. So what you're going to see is a picture that kind of pulses gently between one image and the other, and there's a difference between the two images, so I kind of spot the difference. And in the first case, you should be able to spot that difference fairly easily, because what's been removed is high-level visual saliency area. The second image that I'm going to show you, my computer program predicts that if it's correctly measuring that saliency and removed a lower saliency part from it, it'll take you longer to spot where that change is made. So let's have a look and see how my computer program faces up to the reality of testing. So the first one, hopefully there's a reasonably quick, you'll be able to spot reasonably quickly what the changes are. So the instructions here are very simple. When you see what's changing, don't shout out, leave the others to think about it themselves, and just put your hand up and you'll see how quickly people spot it. So this should have an area of high visual saliency for you, and you should spot it reasonably quickly. Here we go. You can see hands come over. This is exactly the kind of experiment I would do in a laboratory as well, under controlled conditions. So, a reasonable number of people are getting that. Would someone care to shout out loudly? Somebody down at the front there, shout out loudly. 98, yeah. This number over here, 98 is vanishing. And that's what my computer would predict, that you would be able to spot that fairly soon, fairly quickly. This next one is slightly trickier, because what I've done is I've asked the computer to remove a part of it that has a low visual saliency. So it should be more difficult for you to spot what's changing. So again, the instructions, look at the picture. When you spot what's changing, put your hand up, don't shout out, just put your hand up and look smug, because this one's tough. Okay? So here we go. One or two. For those of you who've spotted the change, it's really, really obvious, isn't it? For everyone else, they're all going, what's he talking about? There's nothing interesting there. Somebody can put us out of misery. The young lady in the front row there, Julia, shout out to you.
The windows on the bottom left building.
Absolutely, the whole side left. Oh, now you see it, yes. It doesn't count. So the whole inside this building has appeared and disappeared. So this is a really nice example of how you can take an understanding of the way the human brain works, you can implement that in software and mathematics, you can build a system, a computer vision system, and I actually then would install it into robots, for example, to be able to help them try to process and understand the world. This is part of a bigger project we have called Computer Science for Fun, which is situated here at Queen Mary. The website csforfun.org. In the Octagon, there are a whole load of kind of handouts that you can pick up, including magic books and teacher resource packs and so on, all available free to download from the website. Puzzles, games, lots of things there, all of which tell you about computer science research and computer science fundamentals, but in an easy, accessible, fun way. The magic book's been translated into a whole series of different languages as well, so hopefully you'll find something there that's useful for you. And then the final thing that I wanted to mention was, not only do I go out and work in schools and do outreach and science communication there, but I also run a large European teacher training project called TEMI, Teaching Inquiries Through Mysteries Incorporated. And we're one of the projects that you'll be able to meet later on in the project sessions later on. And what we're trying to do there across Europe is develop a series of mystery-related classes where you use the emotional hook of something mysterious happening, whether it's something that becomes magical or whether it's something that just has a really interesting, offbeat, compelling narrative that actually brings children into wanting to experiment, to discover what it is that creates that phenomenon. So that inquiry side of things, based around solving a mystery, is actually very close to the core essence of being a scientist, because as scientists we find something mysterious in the world and want to understand how it works. So my final thoughts on this, hopefully, is that you'll find some of the resources that have been developed here at Queen Mary useful and interesting to you, but also that you'll take the opportunity to talk to one another, to exchange thoughts and ideas, and basically have a really fantastic time, because that's what it's all about. Putting the fun into being a scientist, because actually it is a good fun thing to be. So at that point I'll say, I've been Peter, and you've been fantastic. Thank you very much. Thank you.
Okay, ladies and whose phone was that? I'm qualified to confiscate that. I'll make your parents phone up to get it back. Right, so now, all the resources, as Peter said, are available in the Octagon if you want to have a look at the various books. And, I'm being subtly photographed. I'll look like I'm doing a talk. Just take your time, it's okay. Right, you will notice there will be cameras, both video and normal cameras going around for all of Science on Stage. If one of them points at you, please try and act natural. Don't do what I did, or try and look like you're having an enriching learning experience, whatever is easier. But don't be nervous if there's one pointed at you. If you have any problems, just let whoever's behind the camera know. We will be documenting various... Are you hiding now? No. Well, it's not working because I've pointed you. You want to get a shot of the crowd? Do they look like they're paying attention? Mostly. Great. Okay, so everyone just look attentive for a second and we'll get that on film down there. So now we have had our official welcome from Queen Mary University of London. We are now going to have our official welcome from Science on Stage. Next on stage is the Chair and Director of Science on Stage Europe. Can you please, I think she's within reach, can you please, here she comes, can you please put your hands together, but not until she gets all the way to the stage, or it will be awkward, for Stephanie Schlunk.
Dear teachers, dear Professor Julia Higgins, dear Professor Peter McOwan, dear ambassadors, dear guests. My oldest daughter, she's 6 years old and in first grade. Some weeks ago she came home and told me, well, Mom, tomorrow everyone has to explain to the classmates what the parents are doing at work. Actually, she was 4 months old when she visited her first festival, so she knew Science on Stage. But to explain it in her own words was difficult. So I said, I'm working for the biggest European STEM teachers network, which offers teachers a stage to exchange their brilliant ideas and come together. Next day, she came home and told me that my explanation was too difficult and she could not remember everything. So I said, I should simplify. And I told her, just think about a huge international bazaar with experiments where people exchange in a vivid atmosphere. And remember 4 words. From teachers, for teachers. And this time she remembered. Dear teachers, on behalf of the whole board of Science on Stage Europe, it's Rosa from Spain, Adam from Hungary, Anders from Sweden, David from the UK, and Michalis from Cyprus. I welcome you, 384 teachers from 25 countries, as well as our guests from Saudi Arabia, Israel, USA, Lithuania, and USA to our Science on Stage Festival. This is the biggest international education fair in Europe and the culmination of our national events in 25 countries. You can be really proud for being selected as one of the best teachers in your country. Congratulations. On behalf of Science on Stage, I would like to thank you for all your time you spent to prepare your project here in London. We know that you are very busy in school, and I guess it's not always easy to convince your headmaster that you have to be here in London right now. And despite all the obstacles, you are here. I think this shows how dedicated you are on the one hand, how education works at a grassroots level, and how inspiring it is to exchange ideas on a European level, and how fruitful it is to learn from each other. And Science on Stage is not only the festival, it's more. It's a long-term initiative, and we would like to encourage you to continue to follow up after the festival. So please, spread the good concepts, the ideas you see here, via teacher trainings in your country. Take part in the excursions to learn more about good schools in other countries, or apply for a travel scholarship to meet teachers you've met here again afterwards when you're back home. Or join our international workshops to develop teaching material together. Use the time here in London to exchange email addresses, phone numbers. You can also do this via our web app, my.scienceonstage.eu. And we support these kinds of activities because we are convinced that for having a sustainable impact, it is important and essential to continue networking when you're back home. The reason why Science on Stage can work on such a long-term basis is our faithful supporter. It's Think Inc., the initiative. They have supported Science on Stage since the very beginning, since the year 2000. And Think Inc. is from the Employees Association in the metal and electrical industry. So I would like to thank Mr. Gollub. He has supported Science on Stage not only with money, but also with time and energy. Mr. Gollub, I step so because I cannot see. Thank you for your support. support because you allows us to organize our festival, the follow-up activities, aiming to encourage school children to consider a career in science or engineering. In addition, I would like to also warmly thank the Queen Mary University of London, dear Professor McOwan. Thank you for hosting our festival. Thank you for the courage to let yourself into the Science on Stage adventure and hosting this big event. Thank you very much. And it is really a lot of work to prepare everything from the program down to the name badges. So I would like namely thank Charlotte Thurley from the chair of Science on Stage UK and the whole team, Bryony, Perla and Dan, for their tremendous efforts in preparing our festival. Thank you very much. Before I pass over the microphone to Mr. Gollub, I would like to finish with a quote from one of our participants. I hope it's okay if I say this now. It's from Sweden, it's Anders, and he wrote us, "As this is my first Science on Stage activity, I didn't really know what was waiting for me. But you have certainly surpassed my wildest guesses. Really an inspiring meeting. I hope that you leave on Saturday with a similar feeling and a lot of ideas for your own classes. So thank you for your attention and enjoy our festival."
So ladies and gentlemen, with no further ado, you've already heard his name once, and you've already given him one round of applause. Can you give a second round of applause too from the thinking sponsor to talk to you about why the international collaborations that come out of Science on Stage are so important? Can you put your hands together for Wolfgang Gollub?
Well, when I'm looking here, I think we did the things right. Welcome. You see, I'm bringing you the greetings from the German metal and electronic industries, in which I'm working in employers' associations for them. And you may ask, well, why do we bother about Science on Stage? And why do we support Science on Stage? Very simple. We represent 7,000 companies working in the metal and electronic industries. And there are huge problems. We are thinking about the climate change, the electro cars. We are thinking about solutions to clean the oceans, and so on and so on. New computers. Well, for that we need young people who are highly skilled. And we need people, and not only in Germany, but all over the world, in global industries, who are facing these problems, trying to find solutions. They have to work together. They have to have good ideas. How do they come to that ideas? You see, what inspired me to become a student in political science and education, that was teachers who showed me that is interesting, and history is interesting, politics are interesting. But the scientists we need now, and the researchers we need now, and the engineers we need now, they need inspiring STEM teachers. And I think it's the best place in the world for a science teacher to be here, to exchange knowledge and good practice with colleagues from other countries. Not only talking about PISA, but bringing people together to overcome the PISA age. And now we are sponsoring Science on Stage Germany and Science on Stage Europe for meanwhile nearly 15 years. By the way, that's just a little bit of the existence of our Gesamtmetall Association, which just had its 125th anniversary. So, 15 years sponsoring Science on Stage. and it's a good investment. And we see more and more that those ideas Stefanie and her team and the board of Science on Stage Europe had in the beginnings when we started to think about a new Science on Stage Europe. The ideas become true more and more, and we are working together better and better. And more the activities of Science on Stage become sustainable, and we need that, and we have to go on that. So, what I wish from you, dear teachers, work together in the spirit of Science on Stage. Let this festival become another successful one, and to set a sign in this direction of cooperation. We have the joint projects here the first time, and Gesamtmetall will give a prize for the best joint project, because nothing else but these joint projects can show better the idea of Science on Stage, the international co-working of science teachers. So be successful and have a nice festival. Thank you.
Now, the point from that, and there are prizes involved, is one of the reasons that you all get together simultaneously in the same city. The reason everyone has come from right across Europe to London is not just because you wanted a holiday in London that your school has paid for. It's because it's important to get everyone together at the same time, and we try and encourage projects that carry on long after the Science on Stage Festival is over. And so next we have a few of the projects that came out of previous Science on Stage festivals. And the first project came directly out of the previous festival 2 years ago. So I'm going to welcome up onto the stage the people who are involved, and they're going to tell, because they were like you 2 years ago, they met at the festival and they came up with a collaborative project. And so can you please put your hands together and welcome to the stage. It's Heidrun, Krista and Isabel. Excellent. Put your hands together for these guys.
Thank you so much, Matt, for this brief presentation, and we are all alike, for sure. So let us start with our presentation. My name is Isabel, this is Heidrun, and this is Krista. We came from 2 countries, Portugal and Germany, and we hope that we are going to tell you a story, which is a story of a beautiful friendship above all, and it was a wonderful experience. And this year, to the festival 2015, we bring Simply Paper Made, but I think we have to go back in time 2 years, and Krista will start our story.
Once upon a time, there was a Science on Stage Festival in 2013 in Slubice, the border between Poland and Germany. It was the first time we met each other. We came from 2 European countries, Germany and Portugal. My name is Krista Müller, my colleague is Heidrun Gollub, and we came from Germany. And here you see us at the fair.
Slowly up, Matt.
Oh, that's not the wrong one.
Not so fast. Matt is going too fast.
Yes,
That's right. Okay, thank you.
our project was our solar system. With this project, young students learn astronomy in a very easy way while doing experiments with simple materials, and here our Portuguese friends.
That's the Portuguese project in 2013. So I'm Isabel. Lina was my colleague, Lina Canas. She is in the first picture. We, besides having a stand in the fair, like everybody, we put up a workshop, and it was in that particular workshop that we had a surprise and met Heidrun and Krista. So Matt, now we can go through. This is the poster of our project, The Sky in Your Hands, which is a project to teach astronomy to people that cannot see, as we all mostly see, to the visually impaired students. And it will endure for some years, as it was born in Spain, but we brought it to Portugal and developed school activities for the students. So,
And so Heidrun and I, we went to the workshop from Isabel and Lina. And after taking part at the workshop, we all quickly knew a few months later we decided to apply to a Science on Stage follow-up activity. Take a workshop to your country. In October 2013, Heidrun and I flew to Lisbon to meet Lina and Isabel.
Yes, I'm lucky I was there. And, just a minute, Matt. Okay, perfect. And this is the inside of the rooms. We prepared a one-day training teacher with the workshop of Heidrun and Krista, the workshop of myself and Lina, and from another colleague from Germany. And we could have some activities to work hands-on with the teachers, about 30 Portuguese teachers, to put hands-on astronomy and science teaching. It was great. It was a great day, and it was a great opportunity for my colleagues and Portuguese teachers to meet foreigner, other countries' teachers, and we understand we have the same feelings and the same thoughts and the same needs. So it was really good to make that bridge. Okay. The story goes on, and I was forgetting. After this, we had a huge surprise. Heidrun and Krista sent me an email. Isabel, did you saw the email? I never see the emails before them. They always see the emails before me. And we had an invitation to go to Berlin to make our workshops all together to German teachers. I said, oh my God, I'm going to do this. Then we calmed down, we planned all the trouble, and we thought it would be a shame if we don't take this time to be together and visit your schools in Germany. So Heidrun invited me to her house and with her family, and they showed me around the place where they live, and especially I visit their schools. So see what now. What? Hello? Okay, here we are, and we had Yes, great opportunity. You are going to tell this great opportunity.
Yes. Okay. In our hometown, we have a special center for students where they learn to work as scientists. In this center, students have a lot of equipment they can use. They are supported by teachers, by retired teachers, and also retired people of the industry and factories. Krista and I work in this center for 1 day in the week. Here, in the Student Research Center, Isabel, Krista and I communicate our project materials and workshops. We presented them to the local newspaper. During Isabel's visit in Germany, she also visited our primary schools where we work together as teachers. At this time in February, it was Carnival, a special cultural event in this season, and especially in my hometown. As you see, the children were masked.
Yes, it was once again a great opportunity to see how the German teachers work in primary schools, and I was amazed with such a great organization and everything in its place. It doesn't mean in my country it is like this, but our schools tend to be bigger. So it was really a good experience, and to share and to talk to the children.
Then it was time to travel to Berlin. We chose the train to show Isabel the different German landscapes, and in Berlin nearly 50 German teachers took part in our both workshops. Once again, it was a wonderful experience to work together. That evening we discussed a lot of ideas, and we started to think about a joint project. Simply Papermate was born. The next month, many ideas came up and were discussed between us, mainly using email. Many materials had to be tried out, and it was time to meet each other. Isabel invited my husband and me to visit her, so we traveled to Portugal. And what do you think? The consequence was we became real friends. And for our project?
It was great for the project we bring this year, because without these meetings it would be much difficult to work together, and we had a great opportunity to put things well thought and planned. These are the images of my planetarium where I work. the activity with the people, the visitors, which have all kind of ages, since the young children to grown-ups and or elderly people. So this activity is suitable for everybody.
Also about children, Islamic primary in all for the primary school children. And here we are. If you want to know more, please, you can visit us at the house in the fair.
And thank you for being here and for the opportunity that Science on Stage gave us to meet each other and to develop all that kind of work and hopefully to contagious all the Portuguese where I came from and also your colleagues. Thank you.
Thank you very much. Hydra, Krista and Isabel. So you can now see if you spend any time in the pub or bar, you are just officially working on a joint project. So up next are some people who met at the Science on Stage before the previous one. So 4 years ago, they're going to come up and show us very quickly about their project. Can you put your hands together for Karina and Zenona?
We present our joint project, which lasted 2 years, not 2 scholar years, fascinating physics.
My name is Zenona Stojewska. I'm from high school from Wieluń, Poland.
I'm Corina Toma from Computer Science School, very Poland, from Cluj-Napoca, Romania. We met for the first time in Copenhagen. We had our stands one in front of the other, and we understood each other very well. And for the second time, the Science on Stage in Slubice, Frankfurt order, we were yet friends. And we talked much about our project, about our students. And at the end of this festival, Zenona said to me, do you want to make a project with me? And I said at once, okay, of course. And but she said, you know, I want to come in Romania with my students, with 16 students. Oh, I say, it's probably it would be more difficult, but it will be very useful for our students.
What have we done? So, we completed the form application for scholarship travel exchange. It was approved and financially sustained by Science on Stage Deutschland. We called our project Make Physics More Enjoyable. The aim was to increase the students' interest in physics learning, to exchange ideas among teachers. We organized 2 exchange trips. Polish students visited Cluj-Napoca in October 2013, and Romanian students came to Wieluń in April 2014.
In the first meeting in Romania, we made some interesting experiments in my laboratory with my students. We presented them to our colleagues from Poland, and also they presented us some of their works. And then I teach some lessons with ICT, with teaching units from my stage 1 or other platforms. And we visited also National Institute for Isotopical and Molecular Technologies. And the students were very interested in some devices like force atomic microscopy and so on.
During the second meeting in Poland, we spent much time in physics lab, doing together a lot of physics experiments. For example, levitation of ferromagnetic object, Leonardo da Vinci's bridge, spectral observation using self-made spectroscopes. We did online experiments, online computer experiments with Coach Lab interface at school and also at Computer Assisted Education and IT Center in Warsaw. We were experimenting and having big fun in Copernicus Science Center in Warsaw. In our free time, we were sightseeing our native towns. We played a volleyball match, sang together. We were also in Salina Turda, salt mine in Romania, and admired the capital of Poland, Warsaw.
For the second year, we worked, we written another application form, and then we changed the name of the project because we think that it's better fascinating physics, it's more interesting. And our principal aim was the same, to boost our students' interest in learning physics, and we have other objectives, and like organizing science festival in our schools and making short videos and PowerPoints presentation of our workings and looking for movie sequences which do not respect physics law. The students love this kind of work. And all our set material are publicated on the internet. See them and inspire from them.
We will give a few examples of our experiments within physics. For example, we measured the Earth's magnetic field. Romanian students using the Helmholtz coils and the smartphone, and Polish students using the tangent galvanometer. We were testing of strength of spaghetti pasta, building bridges and towers. We were also testing strength of toilet paper. As can you see, the lines of paper were very strong.
Other common projects were how to calculate the speed of electromagnetic waves. Very surprising with an oven, a microwave oven, yes. Some very interesting optical experiments and high measurements using the smartphone, also in Bialun and also in Cluj. And the last but not the least, there were science festivals organized in our schools, and our students were also teachers for their younger colleagues. And in conclusion, this kind of project is very good for students, very good for us, for solving together some tasks. And also, I am sure that this project increased our students' interest in physics learning. And also, this kind of project developed the students' social skills and also linguistic, because all our students talk and wrote in English. And science, in science. Thank you very much. recommend very warmly to try such a project because they are very nice for students and for teachers as well. Thank you.
Karina and Zanona, ladies and gentlemen. I couldn't have put that any better myself. So that is the, don't move yet, that is the end of our opening ceremony. I have a few bits and pieces to let you know about before I release you back into the real world. First of all, I have to explain what is happening tomorrow morning, and then I'm going to tell you what's actually happening now, this evening. So tomorrow morning, we will be back in here at 9 o'clock in the morning. So at 9 a.m., we will be back in here for the starting session all together tomorrow morning. I've been told, there's a rumour that some people are going to form a choir. So there will be an impromptu scratch choir. If you like to start your morning with some singing, then there will be singing about science on stage in here at 8:30 in the morning. So if you want to come...
How education works at a grassroots level and how inspiring it is to exchange ideas on a European level and how fruitful it is to learn from each other. And Science on Stage is not only the festival, it's more. It's a long-term initiative, and we would like to encourage you to continue to follow up after the festival. So please, spread the good concepts, the ideas you see here via teacher trainings in your country. Take part in the excursions to learn more about good schools in other countries, or apply for a travel scholarship to meet teachers you've met here again afterwards when you're back home. Or join our international workshops to develop teaching material together. Use the time here in London to exchange email addresses, phone numbers. You can also do this via our web app, my.scienceonstage.eu. And we support these kinds of activities because we are convinced that for having a sustainable impact, it is important and essential to continue networking when you're back home. The reason why Science on Stage can work on such a long-term basis is our faithful supporter. It's Think Inc., the initiative. They have supported Science on Stage since the very beginning, since the year 2000. And Think Inc. is from the Employees Association in the metal and electrical industry. So I would like to thank Mr. Gollub. He has supported Science on Stage not only with money, but also with time and energy. Mr. Gollub, I step so because I cannot see. Thank you for your support, because you allow us to organize our festival, the follow-up activities, aiming to encourage school children to consider a career in science or engineering. In addition, I would like to also warmly thank the Queen Mary University of London, dear Professor McOwan. Thank you for hosting our festival. Thank you for the courage to let yourself into the Science on Stage adventure and hosting this big event. Thank you very much. And it is really a lot of work to prepare everything from the program down to the name badges. So I would like namely thank Charlotte Thurley from the chair of Science on Stage UK and the whole team, Bryony, Perla and Dan, for their tremendous efforts in preparing our festival. Thank you very much. Before I pass over the microphone to Mr. Gollub, I would like to finish with a quote from one of our participants. I hope it's okay if I say this now. It's from Sweden, it's Anders, and he wrote us, As this is my first Science on Stage activity, I didn't really know what was waiting for me. But you have certainly surpassed my wildest guesses. Really an inspiring meeting. I hope that you leave on Saturday with a similar feeling and a lot of ideas for your own classes. So thank you for your attention and enjoy our festival.
So ladies and gentlemen, with no further ado, you've already heard his name once, and you've already given him one round of applause. Can you give a second round of applause too from the thinking sponsor to talk to you about why the international collaborations that come out of Science on Stage are so important? Can you put your hands together for Wolfgang Gollub?
When I'm looking here, I think we did the things right. Welcome. You see, I'm bringing you the greetings from the German metal and electronic industries, in which I'm working in the employers' associations for them. And you may ask, well, why do we bother about Science on Stage? And why do we support Science on Stage? Very simple. We represent 7,000 companies working in the metal and electronic industries. And there are huge problems. We are thinking about the climate change, the electro cars. We are thinking about solutions to clean the oceans, and so on and so on. New computers. Well, for that we need young people who are highly skilled. And we need people, and not only in Germany, but all over the world, in global industries, who are facing these problems, trying to find solutions. They have to work together. They have to have good ideas. How do they come to that ideas? You see, what inspired me to become a student in political science and education, that was teachers who showed me that is interesting, and history is interesting, politics are interesting. But the scientists we need now, and the researchers we need now, and the engineers we need now, they need inspiring STEM teachers. And I think it's the best place in the world for a science teacher to be here, to exchange knowledge and good practice with colleagues from other countries. Not only talking about PISA, but bringing people together to overcome the PISA age. And now we are sponsoring Science on Stage Germany and Science on Stage Europe for meanwhile nearly 15 years. By the way, that's just a little bit of the existence of our Gesamtmetall Association, which just had its 125th anniversary. So 15 years sponsoring Science on Stage. And it's a good investment. And we see more and more that those ideas Stefanie and her team and the board of Science on Stage Europe had in the beginnings when we started to think about a new Science on Stage Europe. The ideas become true more and more, and we are working together better and better. And more the activities of Science on Stage become sustainable, and we need that, and we have to go on that. So, what I wish from you, dear teachers, work together in the spirit of Science on Stage. Let this festival become another successful one, and to set a sign in this direction of cooperation. We have the joint projects here the first time, and Gesamtmetall will give a prize for the best joint project, because nothing else but these joint projects can show better the idea of Science on Stage, the international co-working of science teachers. So be successful and have a nice festival. Thank you.
Now, the point from that, and there are prizes involved, is one of the reasons that you all get together simultaneously in the same city. The reason everyone has come from right across Europe to London is not just because you wanted a holiday in London that your school has paid for. It's because it's important to get everyone together at the same time, and we try and encourage projects that carry on long after the Science on Stage festival is over. And so next we have a few of the projects that came out of previous Science on Stage festivals. And the first project came directly out of the previous festival 2 years ago. So I'm going to welcome up onto the stage the people who are involved, and they're going to tell, because they were like you 2 years ago, they met at the festival and they came up with a collaborative project. And so can you please put your hands together and welcome to the stage. It's Heidrun, Krista and Isabel. Excellent. Put your hands together for these guys.
This brief presentation, and we are all alike for sure. So let us start with our presentation. My name is Isabel, this is Heidrun, and this is Krista. We came from 2 countries, Portugal and Germany, and we hope that we are going to tell you a story, which is a story of a beautiful friendship above all, and it was a wonderful experience. And this year, to the festival 2015, we bring Simply Paper Made. But I think we have to go back in time 2 years, and Krista will start us our story.
Once upon a time, there was a Science on Stage festival in 2013 in Lubice, the border between Poland and Germany. It was the first time we met each other. We came from 2 European countries, Germany and Portugal. My name is Krista Müller. My colleague is Heidrun, and we came from Germany. And here you see us at the fair.
Slowly up, Matt.
Oh, that's not the wrong one.
Not so fast.
Matt is going too fast.
Yes,
That's right. Okay, thank you.
our project was our solar system. With this project, young students learn astronomy in a very easy way, while doing experiments with simple materials, and here our Portuguese friends.
That's the Portuguese project in 2013. So I'm Isabel. Lina was my colleague, Lina Canas. She is in the first picture. We, besides having a stand in the fair, like everybody, we put up a workshop, and it was in that particular workshop that we had a surprise and met Heidrun and Krista. So Matt, now we can go through. This is the poster of our project, The Sky in Your Hands, which is a project to teach astronomy to the people that cannot see, as we all mostly see, to the visually impaired students. And it will endure for some years as it was born in Spain, but we brought it to Portugal and developed school activities for the students.
And so Heidrun and I, we went for the workshops from Isabel and Lina. And after taking part at the workshop, we all quickly knew that we